Good afternoon, everyone. My name is Robert Johnson, and this is presentation 3 for AMGT 402. My presentation is on electric vehicles. I believe that as students of this program, we have only witnessed the beginning of electric vehicles. With this technology still in its infancy, it's easy to find yourself lost in thought about the future and what is in store for the electric vehicle market. Since this technology is growing so quickly and becoming so popular, one would only assume that modern advances would allow such a vehicle to exist. However, electric vehicles are not a modern concept. Robert Anderson, you can see here, he is an inventor from Scotland and is responsible for the inception of the first electric vehicle, which surprisingly wasn't a car, it was a carriage. It was coined the horseless carriage and had a surprisingly simple design. One battery and one motor. The battery used crude oil to produce electric current in a battery that he designed himself, believe it or not. The concept was very environmentally friendly, as the battery did not require any refined oil or any additional processing or the burning of fossil fuels to create. All of this insight and empathy for the environment can be credited to an inventor in the early 1800s before global warming was even a concept. Due to ethnocentrism, many believe that the first electric vehicle was produced in the United States. But in retrospect, it would take another 50 or 60 years for the United States to catch up to Anderson. In 1891, the American chemist William Morrison designed and built the first successful electric vehicle in the United States. It was essentially a wagon similar to Anderson's, however Morrison's design held 6 passengers and reaching a speed of 14 miles per hour. While the wagon's capabilities didn't compare to horses or internal combustion engines, it did, however, spark interest of companies all over the United States. Unbelievably, by 1900, New York City had a small fleet of around 60 electric vehicles that were used as taxis. Even though we've learned that electric vehicles have been around for more than a century, they weren't mass-produced until the late 20th century. And even then, the first of this new breed of vehicle to be mass-produced weren't fully electric, but rather a hybrid. Fueled by environmental concerns and petroleum shortages, Toyota designed the first mass-produced hybrid electric car in the world. 1997 was a benchmark for change, and the Prius hybrid led this change and became a best-selling vehicle throughout the world. An interesting side note for you. Even though the Prius was the first mass-produced hybrid vehicle in the world, Honda was the first hybrid vehicle to be sold in the United States, beating out Toyota before they could even establish a market here. The Honda Insight Hybrid was introduced in 1999 to the United States. The first Prius hybrid produced an astonishing fuel economy and contained revolutionary technology. The advertised combined fuel economy was around 58 miles per gallon and had a range of 550 miles per tank. In addition to remarkable increases in fuel economy, the Prius produced significantly less CO2 than other pollutants. Since its inception, the Prius has taken the market by storm and sold so many vehicles that it appears that the industry has lost count. The numbers from various sources suggest anywhere between 1.8 and 4 million have been sold worldwide. The Prius also contains some impressive technology, including a generator and a regenerative braking that both charge the battery. There are several reasons that draw consumers to electric vehicles, but the ones that stand out the most are that EVs do not require petroleum fuel and they are environmentally friendly. EVs produce far less greenhouse gases and they require less raw resources to produce. In settings like Los Angeles and San Francisco, where smog is trapped by the mountains, reducing emissions is crucial to improving air quality and the overall health of its residents. Another benefit that most don't consider is that EVs require less maintenance, further reducing their overall operating cost. There are no tune-ups, air filters, or fluids to change, and there are significantly less moving parts, increasing overall reliability. According to fueleconomy.gov, EVs convert around 60% of the electricity in the batteries to the wheels, whereas gasoline engines only convert around 20% of the energy stored in gasoline to the wheels. Another consideration is the acceleration of EVs. A typical gasoline-powered sports sedan completes 0 to 60 in around 5.5 to 6 seconds. and a typical V8 or twin-turbo muscle car like the Camaro SS or the Challenger SRT8 completes 0 to 60 in around 4.5 seconds. These vehicles, on average, also tend to complete the quarter mile anywhere between 12 and 14 seconds depending on horsepower, torque, final drive ratio, tire size, and a myriad of other components. Gasoline engines achieve acceleration as the engine reaches a peak RPM, producing maximum horsepower and torque. However, electric vehicles do not have to build up in RPMs or wait for turbos to spool up. Because of the nature of an electric motor, EVs have all of the torque and horsepower they create available instantly from a dead stop. This in turn results in astonishing acceleration off the line. There are indeed many benefits to owning an EV, however, there are a few drawbacks to consider as well. One of which is the amount of time it takes to refuel or charge these vehicles. Rapid charging technology has come quite a long way since EVs have become popular. Even still, it takes hours to recharge these vehicles. And even worse, you have to plan your route quite well or else you may end up miles from a charging station without any way to get there. And something tells me that the average tow truck isn't equipped to charge EVs. Another large drawback is the use of extremely expensive batteries. In the event that the Toyota Prius Hybrid or the Tesla Model S aren't charging properly and need a replacement battery, it will cost you between $2,000 and $10,000 depending on the model that you have and the kilowatt hours that your battery has. Although these vehicles have the capabilities to rival just about any supercar on the road, some of us were lured into the automotive industry as children working on our parents' Camaros, Mustangs, and turbocharged cars. Modifying vehicles has become an integral part of our lives and our favorite hobby. Unfortunately, besides software upgrades, there really isn't much modification or tuning to be done on EVs. The manufacturers will release periodic software updates every once in a while, and it may buffer performance, but that's really about it. Speaking of the benefits of EVs and their incredible acceleration, the Tesla Model S, that you can see here, appears to be the most common EV purchased at this point in time. There are several versions of the Tesla Model S available depending on the motor setup and the battery power. There is also a configuration with one motor that supplies power to the rear wheels, and a second configuration with two motors supplying power to all four wheels, effectively creating an all-wheel drive setup. The Model S P100D is the flagship model currently produced by Tesla. P100D is an abbreviation. The P is for performance, the 100 is 100 kilowatt hour battery, which is currently their highest powered battery, and the D stands for dual motors. These attributes propel this seemingly luxurious sedan to absurd speeds in a very short period of time. With a 0 to 60 of around 2.1 seconds and a standing quarter mile time of 10.5 seconds, the Tesla Model S P100D demolishes just about any other factory supercar on the road, including the 700 horsepower Dodge Challenger Hellcat. There are several viral videos on the internet of the completely silent Model S taking down various high-powered sports cars, from the Porsche 911 twin turbo to the Lamborghini Huracan, and several other vehicles worth 2 to 3 times the amount of the Tesla. Although it appears that the Tesla is making the headlines lately, there are a few up-and-coming competitors that aim to take Tesla and the Model S down. Lucid Air is one of these competitors, and let me say, the Lucid Air, their flagship EV, is nothing short of breathtaking. You can see that vehicle here. The rear seats recline as if you're on Delta One first class. The entire roof is made of glass, and everything in the car is ran by 3 separate touchscreens, including the gauge cluster. The Tesla Model S is a nice car, but the Lucid Air gives us a glimpse of what high-end luxury EVs may look like as the market evolves. The Air comes equipped with more than just show as well. It has the electric motor equivalent of 1,000 brake horsepower and 900 foot-pounds of torque. As you can see here, by all of these vehicles listed, there are several other companies and vehicles that compete with Tesla, including the all-electric Chevy Bolt, which you can see here in orange. The Bolt is considerably more affordable and averages 237 miles per charge. There is some speculation that General Motors actually beat Tesla to produce the first realistically priced mass-produced fully electric car on the market. I chose this subject because I believe that EVs will continue to evolve and will become a successful market segment. Staying current on this technology is important to us as students and graduates because we are the generation that will see this technology reach its full potential. We need to be able to adapt as the market changes, not react to it when it's too late. As more EVs enter the market and consumers grow more confident in purchasing them, we are taught that in order to be a good manager in this industry, we need to be able to see the changes coming for hiring purposes, sales process modifications, and the overall satisfaction of our customers. That's my presentation. Thank you very much for your time. And here is a list of my sources in case you are wondering where I got all that information from. Thank you very much for your time.